एक बार ऐसे करना इसी स्क्रीन पे खुल जाएगा। खोलना है इसी लैपटॉप पे खोलना रहता है।
हाँ इसी पे।
हाँ तो वो उसमें जाइएगा फिर किनारे जाइएगा ऐसे।
A very good morning to one and all present here today. I hope each one of you is safe and sound and is doing good. I welcome you all to our webinar session jointly organized by Indian Concrete Institute Pune and Ghaziabad Center along with Ultratech Cement Limited every Saturday 11 a.m. Our today's session is based on panel discussion on precast execution challenges, that is erection planning, machinery and methods. The panelists for the session are Mr. Amit Barde sir, who is Head of Precast Initiative and L&T Private Limited, Mr. Yogesh Kajel sir, who is Vice President at BG Shirke Construction Technology Private Limited, Mr. Rambabu Lachari, sir, who is Head of Precast Operations at Puja Crafted Homes Private Limited, and Mr. Syed Basha, sir, who is Managing Partner and COO at Excel Precast Solution Private Limited. I would like to thank all our panel members for accepting our invitation and for taking out their precious time to deliver this lecture. It's an honor for all of us to have you on this platform. Now, I would like to extend my greetings to distinguished dignitaries present with us here today. We have Mr. Ujjwal Kunte, sir, who is Chairman of ICI Pune Center, Mr. Prasad Sevakari, sir, who is Secretary for ICI Pune Center, Mr. Arun Kumar, sir, who is Secretary for ICI Ghaziabad Center. We also have with us Mr. Dhananjay Bhosle, sir, who is Convener for SEMCON 2021. From Executive Committee members of ICI Pune and SEMCON organizing team, we have with us Mr. Mangesh Haridas, sir, Mr. Arun Karnik, sir, Mr. Amit Haridas, sir, Ms. Suchita Kalwar, ma'am, and Mr. Ramesh Kulkarni, sir. We also have with us Mr. Vipin Chaudhary, sir, from Ultratech Cement Limited, who is Regional Head for Technical Services of UP1. Moving on, I feel delighted to welcome Arun, sir, for giving us a brief of ICI. Over to you, sir.
Okay, thank you, Vamka. Let me share my slide presentation.
Yes, sir.
Is it visible now? Hello?
Not yet, sir.
Not yet.
No, sir.
Now?
No, not yet.
No,
Not
sir, we
visual.
cannot see your screen. No, sir.
Okay, anyway, if it's not available, then I can speak directly. We welcome all on this 88, our 59, our 59th webinar series of ICI Gadia chapter. This webinar this is 88 in the series of this, and this being organized with joint effort of ICI Pune Center, ICI Ghaziabad Center, and Ultratech Cement Limited. We welcome all our panelists on this webinar, and Mr. Amit Varde from LLT, Mr. Yogesh Kajale, Mr. B.R. Sirke from B.R. Sirke, and Mr. Rama Bulacharya and Syed Basaji. On behalf of ICI Ghaziabad Center, let me introduce, tell something about ICI. What is this Indian Concrete Institute? This institute was formed on September 7, 1982 at Chennai, and just there is some problem in my computer. And our headquarters is at Chennai. We have got 44 regional centers, and we have till now we have 13,000 plus enrolled members, 351 organization members, 256 our student chapter, and member profile are practicing engineers, architects, consultants, manufacturers, research scholars, academicians, and students. Our ICI is managed by Governing Council with President, President-elect, and 4 Vice President, North, East, West, and South, Secretary General, 12 elected members, including two from organization member, 2 past president, 4 co-opted members, and chairman of all ICI center. And ICI centers are managed by the executive committee, forming chairman, vice chairman, secretary, treasurer, and committee members. Our main objective is to promote growth of the concrete construction and its specialization, to disseminate information and train personnel for the needs of changing concept, to collaborate with national and international agencies to identify R&D problems, to institute and distribute awards for the achievement in the concrete construction technology, to arrange national and international workshops, conferences, seminars, and exhibitions, to arrange annual lecture series on selected topics of the relevance of the concrete construction. And ICI Ghaziabad Center has organized so many functions. As I told you, this is 88 in the series, and there are so many talks on the international conference and symposiums which our ICI Center has organized. All ICI centers, they organize their celebrate concrete day on the formation of the in month of September, and concrete day celebrations is being done by all centers, and Ghaziabad centers are organized every year. This year, last year we were online, but this year we did it on physical mode. And many of the and we have awarded so many for our outstanding concrete technologists and outstanding and concrete this year, and and outstanding concrete structures. Because we cannot show the photographs of the I cannot show because of some problems on my computer. Our ICI international branded events are ICI ASCON, Asian Conference on once in the 5 years, and this is a platform in which experts from all over the world participate and share their experience and knowledge. ICI IWC, this is innovative world of concrete, once in 5 years, and an international event combined with exhibition to discuss and disseminate the knowledge. In 2013, it was organized in Hyderabad, and along with the exhibitions and other so many international participants, they have come and participated in this event. We have organized our ICI. We are in collaboration of the BMTPC also, and a joint initiative by ICI and we organize certificate programs for our persons to be trained in for the concrete. And our headquarters, they give annual awards of outstanding concrete technologists, outstanding concrete structures, outstanding pre-stressed concrete structures, lifetime achievement award, north, south, and east, west, and Dr. A. Ramakrishna Award for the best project with Precast concrete in India, Young Scientist Award, Best Student Chapter Award, Innovative Applications for the Special Concrete Award, Best PhD Thesis, and Best Published in ICI Journal, Best Paper Published in ICI Journal, and Best Paper on Innovative Construction Methodology. In collaboration with the international professional bodies, ICI has entered into an MOU with ACI, Concrete Institute of Australia, Korea Concrete Institute, RILAM, Singapore Concrete Institute, and we are member of the Asian Concrete Federation. We published ICI technical monographs, and this year and bulletins also. Our technical committee through format unified codes, standards, guidelines, handbooks. We have so far published 10 our technical committee report. One is fiber reinforced concrete, precast construction of the buildings, concrete admixtures, unified code of concrete construction, recycling of the aggregate for the C&D well, decorative concrete, alternative to river sand, concrete durability, and concrete flooring. This year, the 10th one we have published this year, a handbook on the waterproofing of the concrete structures, and these are available from our ICI headquarters. For members, it is 20% discount, and for purchase of 5 or more copies, we have got discounts accordingly. These available, and our new initiative of social media, e-learning portal, and job portal to support the student members. Benefits of the becoming ICI Life member. On this occasion, I must invite all of you to become Life Up members if you are not yet member of this ICI. And the benefit of concessional delegations fee, access to concrete portal through ICI website, receipt of the quarterly journals, receipt of the monthly bulletins, publications on the concessional cost, and participation at ICI, access to ICI library, and participation in ICI technical committee. And for the organization members also, there are so many benefits, and for the organization member can participate with the free delegations in the ICI events, concessional delegation fees for 2 or more institutional members, and receipt of the copies of our journals. Student chapter, that is very important for us, and this is required because to bridge the gap between knowledge and practice. Because when we are as a student, knowledge is and what we are following in the industry, that is must to learn for the students, and to keep themselves happening in the industry. And the benefits of the student chapters, they are support in calling professionals in civil engineering for delivering guest lectures, support to conduct training programs, workshops, conferences, site visits, etc. ICI update and e-bulletins from ICI to keep abreast of the happenings in the concrete world, access to ICI reference library, concessional delegation fees for participant, and participation in ICI conducted competition, publications of the ICI at concessional cost, favor of the entrance fee to become permanent member of the, and that is there are so many other benefits, and every year also we provide best student chapter award at the center also, and at our ICI Ghaziabad chapter center. Number of the guest lectures organized, we have kept some criteria for them, and minimum 3 lectures are to be organized by them, and workshop 3 and 5 programs, and number of the site visit 1 local and 3 in all. So site visits, we also take the students to the construction site to make them aware of what is happening in and around, and how they can utilize their knowledge after passing out. And student fests are also being done. And so with this, I welcome you all once again in this webinar series and panel discussions. And thank you very much for the hearing. I am sorry that I could not upload this our program, and there was some problem at my end. Anyway, we welcome you all, and please, Bhumika ji, please make the presentations.
Yes, sir. Thank you so much, sir, for giving us a brief. Now there's a small announcement for all our participants. I request you all to please keep posting your questions in the chat box and pertinent to the topic, and we will take up all your questions towards the end of the session. Moving on, now I welcome Dhananjay sir for panel discussion moderation. Over to you, sir.
Yeah, good morning, everybody. Actually, this year we are focusing more onto the requirement of the industry's present situation, how to tackle the present situation post-COVID and those type of things. So ICI Pune Center has decided to take up the automation need of construction industry as a priority subject. And this year's SEMCON, we are organizing for establishing more and more insights inside the precast execution related aspects. So this webinar is a part of that series, and the final event will be in the month of December 10th and 11th, where this SEMCON event, International Conference on Advancements in Precast Technology, will happen. Like as everybody is aware, since the construction scale, speed, quality, all these requirements are becoming demanding day by day. So we are trying to create awareness in automation processes which can follow in construction industry, which are used worldwide everywhere. So we are trying to see which are the hurdles, where people are facing more problems, which things need to be discussed on platforms like this. So therefore, we have gathered these experts in the field of execution of precast projects. Today, we have with us Mr. Amit, Mr. Rambabu, and Mr. Syed. There is some update about Mr. Yogesh Kajre because of some unavoidable circumstances he could not join. But we will start our discussion. In this discussion, whatever doubts you have or whatever queries you have, you can start asking those things, and our team will scrutinize the paper questions, and we will ask these questions also to our panelists. So today's main topic is related to the precast execution challenges related to the erection activities. So now I would request Mr. Rambabu to throw more light on general erection process, then we can go into the challenges and different aspects of that. So Mr. Rambabu, can you show us some general erection procedure, like how the erection happens on site, and throw some light on that?
Sure, sir. Good morning, everyone. So normally people think that precast is so tough and then it cannot be adaptable for our projects. But if you have a proper vision and you have a good methods in place and then some knowledge at the background, definitely we can do wonders in the precast. And that too, in the precast, people think that erection is too costly and then we can't avoid, we can't able to avoid it. We can't able to afford it. So people normally thinks that, but there are a lot of things in the Indian, there are a lot of machinery and the systems are placed in India which can ease the precast construction. So let me share my screen and show that the presentation on the precast process. Hope you guys are able to see my screen.
Yes, sir.
Yes, now we can see. Yes.
Oh, you can see. Yes, sir.
Yes,
so
yes.
in the erection, first of all, the heart of the erection is called crane. So this is one of the building what we are doing at Hyderabad, the complete duplex floors, and there are 5 duplex floors. So technically it comes to 10 duplex floors in the Hyderabad location. So when it comes to people think that what is meant by erection, erection is nothing but keeping the element into its respective position by using a crane. So for this, lot of tools and tackles will be required. That one we will be discussing in the later stage. So coming to next is the process of erection. So we have a process in place called it starts from setting and ends with the structural screed. The setting and marking is nothing but making a. We normally use the total station for all our constructions, even though it is Maiwan or regularly. So here also in the similar way we have to use this total station to mark the coordinates of the elements. So in the right hand side of the picture you can see the lines marked that where the panel has to sit exactly. So the next stage is the level. Normally in the precast we have a 20 mm tolerance is there. So that is like normally elements can't be produced up to a 0 mm accuracy, and also we need to have a gap between the two elements of 20 mm. So for that what we do, that where the balance has to sit exactly. Sorry, I'm getting my sound. I'm getting the resound.
Okay, I have muted him.
Hello. Yeah.
Rambabu, you can
I'm
continue.
getting the I think that's muted, no?
Yes, yes.
Yeah. So next is the fixing of the level. So if you take any element, it has to have a proper, it has to sit in the proper level. So for that, normally whatever we do the structural screed, there will be undulations of 5 to 10 mm. So that has to be, that can be taken care by using the sim pads. So in the right hand side pics, you can see that the 30 mm sim pad has been placed over there, and then the lines of the panel where it has to be placed, it has been clearly marked. So then next comes to the erection process, what exactly it is. So before lifting the element, we have to have a system called quality check. So we should have multiple quality checks in the production as well as in the erection before it gets lifted. Why? Because this is the one which eats the time if it doesn't do this proper checking properly. So and then at the once it comes from production to the site, and then it has to be, if the site is so small, and then it can be placed in one particular storage rack. Otherwise, we have to have a multiple storage racks where we have to keep at multiple locations. So, like for the lengthier buildings, we should have multiple rockets, and then the crane will be either keep on moving left, right, center. So in the erection process, basically, once we lift the element, and then it goes to the place and then fix it. So during the fixing only, we face a lot of issues like the double tube doesn't match, and then those things will be coming. But if as I told you earlier, that if the quality checks are properly in place, so each and every element can erect in within 15 to 20 minutes. So in the 10 hours of shift, we can erect comfortably 20 to 25 elements in 10 hours of shift by using any type of crane. So there is one more thing called while erection. People normally the erection engines looks from their point of view, like, okay, my structural things, my element sit in the proper position. That's it for me. But we should also look into this MEP inserts. Why? Because it plays a major role. If it doesn't care, like the panel has to be placed properly. That in the framing plans we have a mold phase and then travel phase. We should maintain that. If you rotate it, then what happens is the MVP inserts go something the other side. Sometimes mostly what happens is for the typical floors, the double tube positions from the left and right center will be the same. So if you can erect the element in one direction, also you can rotate the element by 180 degrees. That time also it will get erected, but the MEP, all the MEP inserts will go for a toss. So we need to really look into that MEP things also. Here I have shown the 3 examples. One is by using the crawler crane, and second one, even by using the hydraulics also we can do the erection of 7 to 8 ton capacity. So next, this is the complete finished erection slab before the screed. As you can see, we have a multiple stages you can see. So it's better to ideally to do this erection in the phases instead of doing in one go, which gives a comfort in terms of speed basically. So what happens is in the left hand side you can see the screed is happened, and the right hand side the screed is to be done, and the third and the middle one screed is to be done. Right hand side the grouting process is happening. So if you plan this way, the pores wise, then the erection will be more easier and then more comfortable. Once the erection is placed, once the erection is done, then normally we fix the if it is a slab, no need to do anything. If it's for the walls, we have to use the push-pull props and then fix it with the flush anchors to the ground. And then what to do the up to maximum extent. We need not to do the complete 100% plumb. You can have some 5 to 10 mm tolerance, and then you can leave the hoist. Otherwise, the moment until you doesn't leave the hoist, what happens is the time for the element will keep on increasing. So our ultimate aim is the moment it is in place, you do it up to maximum extent, and then you release the hoist. Then only we can achieve this speed in the erection. Next, coming to the alignment of the elements. So once the alignment is done, to do the alignment, all this if it is we are going to do the alignment for the wall, for the residential or for the commercial, whatever it may be. So for that, all the corners of the all the panels in the room has to be erected, and then we have to see that we have to adjust the push-pull props, and then if props, the additional jobs to be placed to get the dimensions as well as in the right angles and also the verticality in place. This is more important, the most important thing in the erection process. If you do any mistake over here and then you grout it, and tomorrow you can't do anything. So you can see this. We are doing one building with the complete grooves. As you can see how the alignment is properly done with the complete one panel to the other. You can see almost some 4 or 5 panels are over here, and then you can see the line is matching for the 4 panels. And then the right hand side pic, you can see 2 people are measuring the room dimensions, and the other guy is adjusting the prop. So once again, I'm saying that this erection, in the erection process, alignment is the more critical thing. If it doesn't do proper over here, then we will be ending up doing a lot of additional works once the grouting is done. So the next major thing is the packing and grouting. So once the erection and alignment is done, then we will have a provision of MEP services in all the precast elements. So what we need to do is we have to clear the conduits, and if there's any connection, the slab to wall or wall to wall connections, those has to be cleared before we do the grout. So once we get the clearance from the MEP team, and then we have to seal this joints. As I told you, the precast mostly we go for the 20 mm joints. Otherwise, there is a movement joint of with the up to 100 mm, 200 mm it requires. But here we need to do the additional range for the 2 panels, and then do the proper shuttering, and then do the micro concrete. That in the concrete, preferably we have to use the non-shrink grout instead of cement, so that it doesn't get shrink once it is grouted. And then the mixing of the grout also plays a major role in the leakages further. So all the manufacturers normally they mention what is the water cement ratio to be maintained, and then they mention clearly on the bag itself. So only the thing is our supervision has to be more precious, so that we will not end up in problems in the latter stage. So, and then you can see this is how the grouting packing is done. You can see this baker rods, and then this baker rods to be removed after 30 to 40 minutes. It's not that one time use. We can use this for the multiple times. So in the second example here, you can see where are the external outsides where we can't approach and then do with this baker rod or the foam sheet. Then we can use this electrical conduit with the foam sheet and the bending wire combination, so that we can in the loose condition while erection we can tie it up with the element. Once the erection is done, we can pull this conduit thing from the inside and then tie it to the panel inside. So this is most required for the elements which are coming at the outer face. In the inner face, we can use this normal regular baker rods. So here one more option where if you have some OTS, where you have instead of doing scaffolding from the bottom, if you have an OTS, you can make holes in the parapet or something. But here also one more thing is you have to clearly see that okay, tomorrow you should be in a position to properly pack those things. So in this we did this, we have successfully tried this and succeeded. Instead of doing scaffolding from the 10 floors, by using the 1 floor, we can do the packing for this element successfully. And then when it comes next, it comes to the grouting. So as you can see, the 3 stages of the grouting. The complete grout has to be put into the to use the mechanical operated machines. We should not do any hand mix. Why? Because if it doesn't mix properly, then we'll be ending up spending a lot of time at the latter stage. So in the first, you can see the grout bag closing, and then the 4 to 5 liters of the water, and then mix it properly at the required time, and then take the grout into the any vessels, and then pour it vertically. And the grout has to be in the free flowable state. It should not be a so stick. So you can say once the grouting is done, this is how it looks. And then the baker rod, once the grouting is done, we should remove the baker rod. The normally grout sets in 30 to 40 minutes hardly for any if you take any MNC manufacturer. So we have to remove this breaker rod after 30 to 40 minutes to see that okay, the grout has reached to all the corners properly. If not, you can just loosen the things and then redo. Instead of doing 1 day, 2 days later, you can visually see that. And when once this grouting and then all the works are done, then the final stage comes to the structural screed. So structural screed is nothing but we have a multiple elements will be placed in one location to get the monolithic and then the seismic proof building. It's better to have a structural screed. Basically, normally all the structural engineers recommend for that. So it will be having the thickness varies from 40 to 100 mm. Even on the hollow parts also, we need to do a structural screed so that the monolithic construction the joint established. So after this completion, once this all these works are done, then there is a provision. We will be leaving a provision for the MVP and then other services kind of thing. So for that, once we have to have a proper inspections by the multiple departments before we do the screed, like MVP and the structural and then the architects, if required, some any PMC to be inspected thoroughly. Once the screed is done, we can't do anything. Okay, then next comes to the panel. So this is how we do the screed. In the first pic I have shown you left hand side, we have done the screed, and then if you compare my complete action pic from the first one and this one, you can see the in the faces how the construction is moving. Port 1, Port 2, Port 3. Like that it should go. Can you please play the video? I have prepared a 2 minutes video which gives the feel of the erection.
Yes, sir, playing.
I could not able to see that. Is it video is playing or I need to play?
So we are playing it.
Yeah. Sorry, still I could not able to see.
Sir, we are unable to connect. Can you please play it from your end once?
Yeah, I will play.
Rambabu, we are not able to hear the background music, so maybe you can start explaining
Yes, sir.
whatever the points. Yeah.
Yeah, I will do. So here you can see this. Once the crane is reached, the floor was ready with the starter bars. So then you can see this one after the other. All the elements have been erected. Once the vertical elements have been erected, then there is this called the grouting. What we are seeing in the screen now. So once the grouting is in place, and then this is actually the one which is shown in the video, we'll do in the final finisher stage. So once all the verticals and then are being grouted, then it goes to the slab erection. So in the slab also we need to do the grouting and then the structural screed. Once that is the grout and structural screed, then it goes to the next further stage. So you can keep on see the video. Just repeat it. It shows in the 3 dimensions how the erection happens. If somebody wants to really experience this kind of thing, they can fix the camera to this tower crane, and then they can record it for a period of 3 months or 6 months, and then they can compress it So here I will show some examples of the buildings which we have done. So this is one of the big projects at at Bangalore Shobha Remakers, which is spread around 88 acres of land, and it is a 10 million SFT. All are G+12 and -2 G+12 and 14-story buildings. So in the puja, actually, we know for the brand in the Hyderabad, which who delivers the unique products. So even all our projects, we are doing completely in the precast. As you can see, these 4 pictures, which shows that it can't be done in the precast, but still we have taken a chance and then doing it in the precast. So you can see this building having coming up with the duplex floors. Out of 5 duplexes, we have to finish 3 duplexes, and then it is having a grooves in the and throughout the building, and the different planter boxes also having a different. It is also having a different group pattern. And then all the double-eight columns and then double-eight seat outs we have. So you can feel this how it looks with the different in the different angles. It is basically, and this is one what we did in the Mangalore. As you can see, this building is completely as you can if you observe this the portico of the car parking portion. So this is the complete 4 meter by 10 meter slab which was hanged, which is a complete cantilever, and then where we did with the help of inverted beams and the precast panels, we could able to achieve this. As you can see, the 3 stages of the villas, and this is one more building what we are doing at the Vijayawada, which is having 12 meter by 10 meter span. So these are all done with the complete pre-stressed cast in situ columns and pre-stressed beams, and then pre-stressed solid slabs. So here you can feel this the span of 12 meter by 10 meter, and then the height of 4.5 meter. So what I'm trying to say is, in the precast we can do wonders. Only the thing is, our thinking should go positive towards the precast. Then anything can be achieved. Lot of sources, lot of resources, lot of manpower, machinery, manufacture. So many things are available in the India. Only the thing is, we should think positive towards the precast. And this one more project which we are doing in Hyderabad. This is the 10-meter height retaining walls, which we have erected only by using the 50-ton crane. This completely done with the foam liner with the stone finish, and then this wall thickness of only 20 mm. 20 centimeters. So if you want to do a 10-meter height retaining wall, if in the cast in situ you will be ended up doing some 600 in the bottom and then 150 at the top. But we could able to achieve only 200 mm thickness by using the geogrid and then the technology in the precast we have. So these are multiple directions, the multiple peaks of same thing. Over to you, sir. I think I have covered the erection process.
Yeah. So, Mr. Rambabu, thanks for the explaining general process of erection, how it happens right from the beginning. Now, I would request Mr. Amit Barde to explain in general what type of challenges are generally faced in erection of these elements on site. So he can throw some light on that, and then we can go into the details of these things. So Mr. Amit Barde, can you throw some light on what type of general challenges are faced on site during this erection process? I think,
Yeah,
Mr.
good morning
Amit,
to
your mic would be, yeah.
yeah. Can you hear me now? I think camera also I'll just turn on just for the sake of it. But yeah, good morning everyone.
Yes,
I think first of all, before we start, thank you very much for ICI Pune and ICI Ghaziabad chapter for the invitation. I guess we have about some 700 people, so it's fascinating to see the interest in precast, and it's also very pleasing feeling. Let me share my screen. I just have a couple of slides. Okay. You all can see my screen now?
Yes, we can see.
Yes, sir.
Right. Okay. So I think Mr. Rambabu explained the erection. I'm not going to repeat that, but a couple of things just so that you can see a different flavor of precasting from a different organization, and then I'll get into some of the challenges that we have been working on last 6-7 years. I think I joined L&T about 9 years ago, and initially it started with a focus on residential construction. And then we have ventured into commercial, industrial, even some of the warehouse projects, and also some of the challenges. But this is actually one of our flagship projects. I think that kind of set the benchmark for precast in residential construction. This was done for Purvankura developer, Provident, which is their for the residential side. And like I said, the precast, when L&T started the precast initiative, it was geared up for large volume housing, right? Anywhere that is more than 3 to 4 million square feet. This project is about 6.6 million square feet. We had started with about 66 towers. Phase 1 and 2 were completed in about 2017 time frame, and about half of it's about 32 million square feet. And the reason I'm showing the pictures is this is why precast is getting the momentum that we are seeing now for that kind of volume, that kind of quantity, or the built-up area. And second thing, what we are focusing from our side is just because it's precast, the end user should not get anything different than what he's used to seeing. So you'll see this in the pictures now, that the finished buildings are going to look exactly what they're used to seeing. Even interiors, when the flats are finished, you're not going to see any difference. So we are taking a lot of care, attention to details while erecting, while designing, to make sure that the end product, when you see or when you walk the flat, at times even our own engineers would not be able to find the joints or where the different elements have been put together. That has been the goal right from the beginning. And it's seen from the client also. We got a repeat order from Provident. This one building that I showed, it was finished from the ground level to the terrace in flat 3 months. That's the speed of the precast what we are envisioning. Now, when it comes to erection, again, from a contractor's perspective, now, for a minute, if I even forget the end user or the client or the speed, from our side, we are getting or reaping the benefit of having the reduced manpower. Even in the starting stages, where we were looking at about 30 to 40% improvement in the productivity, where we were learning precast, that can be easily ramped up to even 55% improvement. And the main advantage that you will see is less activity at site, right? If you are looking from a contractor's perspective, again, I am not in this business as a precast manufacturer, right? L&T is in the business of construction or constructing residential or commercial buildings. So we are converting to precast because of that inherent inside demand, saying you need to do something different, or whatever conventional ways are not giving us the benefits. And if you see in these pictures also, compared to any conventional construction, this picture now, especially the picture on your left hand side, it's one of the initial pictures from that same project, Provident Sunworth. And this is not taken on a Sunday, right? This is taken on a full working day. If this is a conventional construction site, you are going to see an army of people walking around, material stacked, safety screen installed. It's going to be a busy site. Here, there is a gang of 15-20 people. They are trained specifically for this construction. They are well aware of what they're supposed to do every day, and they are just finishing or working towards that target. Right? You don't. L&T is really big on safety. I don't think anybody else in construction industry has been putting weightage on safety as much as L&T does. And you don't see the safety screens in here because the walls are already there, right? That we don't need that setup. And these 15 people are going to have their daily target of whatever 30 elements, 35 elements per crane, and they keep completing the project. This is where that erection planning is going to come into your view, right? It is a complex building, right? Commercial buildings are easier to build when it comes to the structure. Residential, if you see this picture itself, it is fairly clear that there are intricate elements, right? There are in and outs to the small spans. There is not a lot of space to walk. When we say these elements are supported with the push-pull props, a lot of times these push-pull props for the two elements in the 90 degrees are going to hit each other. So that is one of the biggest challenge. How we are looking at it is planning. All your devil is in the detail. Like if you start hitting these issues at site when they start erecting, you are going to have trouble. You have to plan even before these elements go at site. You have to expect these challenges in advance. Some of them could come from your detailed planning or review or your detailed awareness of the design. That's why the design and construction management has to be together. That's why we have in-house design department. So these people who are designing are exactly or very familiar with the site challenges. But that planning could come either from your drawing table or from experience, both, but make sure that that planning has been done before these elements hit the site. The second thing, if you see in this picture now, your number of cranes, right? Everything is revolving around productivity. You want to build faster, and just to give you a comparison between your conventional, which is of course the aluminum formwork system, which what L&T started about 20 years ago, and we use that system still in many of our projects. But if you want to start a new tower, let's say you plan for 4 towers going together and you want to add another tower, you have to buy an entire aluminum formwork set for that tower, right? In precast, your factory is already there. You have 4 cranes. All you have to do is probably add another crane rental, and there is not a substantial investment. Your factory is planned already where it can cater for that plus or minus demand. Of course, it has its own range, but within that range, adding a tower or two, it's not going to be a big significant expense. Manpower is already very less, and you can quickly ramp up that speed. So it depends on what you want to do. On these similar lines, again, we just took up last year another big project on the success of this Providence and One project. This is going on now in Navi Mumbai. This is for Sidco housing for the PMAY scope. And this actually is what we are boasting now, where the precast technology, we have brought it to mainstream, right? To take up a project of this volume, this is one of the largest order for our residential unit itself in all entire residential construction. And to take that order and commit to the clients, and we are doing to do this using precast technology, it itself speaks volume about how we have adopted now and how we have brought the precast technology to an acceptance level even within the company. Outside, of course, it is going on. So that speaks volume what we have been doing, how the end user is accepting. Sidco being a government agency, also there were several approvals in place that we got it. Now what you see on the screen is where we are taking the next step to the productivity benchmark, right? You want speed, of course, everybody wants speed, especially when the PMAY schemes were announced, housing for all was announced. We wanted to even build faster than your neighbors, right? Everybody else has done that. If you see Hong Kong, Singapore, most parts of China have gone through that process of housing. What we are seeing it now, but if they have done it in 20 years, we are targeting to do it in 7 years, if not 7, probably 10 years, but it is still at a staggering pace. And that's what the benchmark was for this project. If you see on a broad average schedule, we are targeting to build 30 floors per month, right, using whatever resources we have, and that will translate to about 8 flats per day. And all these will be done using more than 1 lakh elements in that overall project. So that's where what the today's theme of erection management, erection planning will come to front, because at this scale, let's say I'm doing about 66 towers, I'm doing 1 lakh element, you have to plan it well. You can't use the conventional ways of Excel planning, you can't use the conventional ways of construction management itself, right? Because you are now doing element by element construction. In CIP construction, usually you will be focusing on floor by floor, right? Usual, if you go any site office, oh, kitna floor kiya, that's what will be tracked day in day out. Here kitna element kiya, how many elements you are erecting per day is being tracked, element by element. That kind of detail level of planning is needed. This one other thing I wanted to put it in front. I think Mr. Rambabu was also saying you have to have positive about it. And yes, we have gone through last 6-7 years going door to door saying, look at precast. And that I think page has turned now where we are getting now the request the other way saying, I want to do it in precast. You tell me how you are going to help. And that is coming from both the government and private clients. So that's a good sign. This one thing, I think elevations, this is architect Hafiz contractor on the project, and they had set saying, even if it's a PMI housing project, I want to have my own brand. So the elevations are going to be unique and different, not your conventional buildings. And then converting the same things using precast was the challenge. But we sat with architect about 6 months. That's where I would like to again repeat again and again. If you are a client, if you are an end user, if you are a designer, that coordination is the challenge, is the biggest challenge that I am seeing. It is you have to anticipate everything on the paper, you have to anticipate everything and build right on paper and make sure it flows on well on site. But that challenge, if you do it really well, it will help you where your productivity is going to be even more than what the precast speed that you anticipate. So with that, this is the actual photo of this project which is ongoing now. We have 5 tower cranes that are building simultaneously about 10 towers, and those will build about 60 towers going forward. We are already on the 9th and 10th floor in many towers now. But the challenge is, I think today's theme again was challenge. So if I have to look at this challenge, if you see the grooves is what Hafiz contractor wanted, and they were very particular about that. So doing that groove coordination, we already see in Mr. Rambabu's presentation also. That is something that it is the conventional team. We have one phase which is going using conventional construction also on the same project. And what we are seeing is the effort required to build these grooves in conventional system are far more than what we are actually putting in precast system. Again, if planning is done well, coordination done well, of course we used BIM, so that has helped a lot. But once that system is in place, you're building everything on the ground, you're building everything horizontal, right? Pouring concrete where the grooves are set up vertical versus pouring concrete where the grooves are set up on the horizontal bed. They don't move a lot. Vertical, there are challenges to keep the alignment and all. So that precast is actually working really well. Another thing, if you see my pointer now, this is actually the refused floor balcony. This on the 8th floor suddenly jets out, right? This entire, we have an open shaft, and at 8th floor we have refused floor balcony, and every floor, at every 2 floors it will come. So now if you see this element, this entire balcony and the floor will be cast by 3-4 elements. Now this in design, it's a day-to-day affair, right? We are doing projections, not an issue at all. But when it comes to installation or erection, you have to anticipate that when this element is sitting on its own, this is the same element that I'm showing, it is going, that projection is going to work against the gravity. It's going to try to topple. You have to make sure that it doesn't topple until the next element comes and sits on it. This usually is a challenge in conventional construction only for the formwork, because the entire formwork floor will be set up. They will take care of that small projection. But now here in precast, suddenly the small projection, because the element is just sitting on its own, it becomes a big design consideration. It becomes a big hassle at the site. You have to make sure that it's planned well. It doesn't rotate. One is, of course, it's tight. So making sure that it doesn't fall is not a big deal. That we will take care of it. Making sure that it doesn't slightly rotate before the next element is placed, so that the alignment is not messed up. That is one big challenge. The second thing, again, I saw here. Generally, if you see conventionally, whatever we are doing now, precast, you need the repetition. You need that same units being repeated again. So generally what you will see is from the first floor above, this building also, this is my stilt level. This is my first floor where the residential building starts. And we have been doing that traditionally. First floor precast starts, and then the bottom floor is done in conventional construction. Now in this project, because they had these grooves and we wanted to align that, doing this in conventional would have been a challenge, because whatever you do, formwork shifts in and out and all, and you want these all in one plane. So what we took a call is, this is done even at L&T for the first time, is hybrid construction. So what we have done is, I cannot do the entire cast in place or the still floor in precast because many number of molds, those don't repeat. We don't have that kind of repetition. So we figured out that entire elevation where only the exterior, where I wanted the coordination of the grooves and planes, only the exterior on the floor plan was converted to precast. And then the interior was poured against those precast panel in a hybrid construction, a monolithic pour. So that design approvals that we went through it and took it. But that has helped a lot, where I get the same finish now. I don't have to worry about it. We absolutely did not want plaster on that because there is a lot of maintenance. Plaster is not working. That's why we shift to aluminum formwork 20 years ago. And in all our buildings, we are literally at zero plastering, external for sure, even internal. So that precast solution has worked really well, where we don't have to worry about now two different finishes. So with that, I think I'll give it back to Mr. Dhananjay. That's the overall erection, especially residential sector. Of course, I have some more information about the challenges in other areas, commercial and all, that will subsequently come. Thank you.
Yeah, Mr. Amit, that was a very elaborative explanation about the general challenges that we face in erection of precast elements. Now, I would like to ask Mr. Syed Basha about the infrastructure requirements assessment, like how do we need to assess the infrastructure requirements for erection purpose? Like what are the prerequisites to be taken into consideration for planning these things? So Mr. Syed, can you throw some light on that?
Yeah, good morning all. Yeah, Mr. Amit and Mr. Rambabu explained in detail about erection process and everything. Here one challenge, before going ahead with any project, first is logistic plan. It dictates whether this project is suitable for precast or not. The logistic plan itself, it gives in detail, which kind of equipment required, what kind of, how many cranes required, all these things. And second thing is, yes, few projects we will not be able to deliver precast. The reason is, lot of, logistic challenges. So logistics is major, criteria before taking up any precast project in this, especially in India. The reason being the infrastructure. Yeah, most projects we can go ahead with precast. We can plan it properly as well as in detail everything. But existing town planning and all, it won't allow us to take up few projects. I'm talking about individual houses like that. So this kind of
you mean to say,
yeah,
you mean to say that we need to do the recce of that site, whether the roads are approaches and those type of things.
Yeah, approach roads and road sizes, and any challenges with the services like overhead services, underground services, which will be bottlenecks for to deliver those kind of projects in precast especially. Otherwise, in open areas we can plan it properly and we can minimize the what you call the machinery requirement. We can easily set up and we can decide what kind of machinery is required in advance. These are the few challenges, bottlenecks I can say in erection point of view. And yeah.
Have you faced any time challenges about the turning radius of trailers or that type of things while planning this type of
recently, last in 2017, yeah, 2017, when we started this hunger-free city of Bangalore, the Indira Canteen project, those setting up the canteens in in very difficult locations, we have faced a lot of challenges. Not only with respect to infrastructure, yes, the services, the existing services like overhead cables, drainages, everything, all these things.
Okay. Okay, so when it comes to logistic planning, do you also take into consideration the site areas like how the stockyard to be planned and from where the lifting has to happen and those type of aspects also?
Yeah, complete logistic plan dictates complete, not only equipment planning, resource planning, and yes, stockyard. Better to avoid stockyards on site to minimize just in time. That's how we have to control in factory. Just in time, we have to get the materials. It will minimize the double handling and double handling cost also in terms of resources, both machineries and manpower. So we have to minimize stockyard on sites.
Okay, so does it affect the efficiency of the crane? Because is there any time you face any challenge in making the crane busy all the time if some trailer doesn't come in exact expected timing, or how is that? Like you have synchronized the trailer movement and the crane movement, something like that?
If we synchronize and we can streamline things in the point of logistics and trailers, these challenges will be there always, because yes, what you call the loading just in time, first come first out, last out. This kind of things we have to synchronize. Then only the things will move and efficiency of the cranes will be we can use much better.
Generally, what is your observation? Like how many elements you could erect in a day by using this type of just-in-time method versus if you have a stockyard on site?
There are two different types of equipments available, like tower cranes. The efficiency more, we can go ahead, minimum 40, average 40 elements per day. Whereas with only let's 50% efficiency of the mobile cranes, we can deliver only 20 number of elements. Even the cranes also the productivity of the project delivery. But we cannot use the tower cranes. Multi-story buildings we have to use, and for villas and all mobile cranes.
Okay.
All this will cost.
Yeah. Okay. Okay. So I think we'll move on to Mr. Rambabu about planning of this erection sequence and how it is happening on their sides basically, and what type of precautions they are taking in planning this erection sequence and erection layouts and the sequence of those things. Mr. Rambabu, can you throw some light on that?
Sure, sir. Actually, I have in the erection.
You have to start your camera also. I think your camera, you are not visible.
Oh.
Okay.
Okay.
Yeah.
Yes, sir. One minute. So actually, when comes to the erection sequence, as I told you in my presentation, that we should break the building into 2 or 3 ports. Then only we can able to get the actual speed. So that is most important in the erection sequence. So if you break like that, then you can do a multiple activities at the site. So what happens is if you plan the entire floor in one go, so the grouting team won't get the work front till they complete the entire floor. So if you once you break into the thing, then the erection team will get the work. Erection team will be working. Erection is happening in one floor, and the alignment is happening in the third floor, and the grouting will be happening in the third floor. Then again, the slabs erection will happen in the port 3. So like that, 1, 2, 3, you have to play around. So in that, actually, I have taken one villa as an example, that in the day 1 to day 7, what we need to do. So that is not since the villa is so small, so I have not divided into the different ports. So let me share that screen.
Okay.
Can you able to see my screen now?
Yes. Yes, we can
Yeah.
see that.
So here you can see this. Typically, this is the framing plan of one villa. The red color one are going to be erected on the day one.
Mhm.
So as I told you, by using the mobile crane, we can erect around 20 elements per day in 9 to 10 hours of shift. That is the regular average in the mobile crane. Whereas in the tower crane, we can, as Syed Basha told, we can pull from up to 30 to 40, provided there is some hollow core slabs or some solid slab. If all are vertical elements, we can be ended up doing only maximum 16 to 20 elements, even by using the tower crane. So you can see in this sequence that in the day one, we need to erect the left hand side all wall panels, and then the right hand side we need to be and the right hand side need to do on the second day. So once the on the second day, you can see this right hand side the wall panels have been erected, and the left hand side slabs also have been erected.
So this is about that Mangalore villa you were talking about.
Yes, sir.
Okay. Okay.
Okay. So here you can see in the bottom I have written that installation of 6 numbers of panels at the right, 6 number panels and as well as slabs and the stair flights. Then comes to the day 3. So day 3 is where we need to do the concreting of one villa. So there all the MEP services and the casting work to be done in one day. So this day actually our crane will be ideal. So that day what we need to do is we have to have another villa backup. So that that day we need again for the other villa the day 1 starts, and then these are the day 3 ends over here, and then again the day 4 we go for the first floor elements, as I have taken some 15 elements of been taken. Then again in the second day the slabs of the left hand side, and then also the walls on the right hand side. So what happens is if you see this the day 4, once we erect these panels, you can see this one room is completed. So we need to do the alignment and the grouting parallelly to save the time. So that then only we can able to erect the slabs on the next day. So you can so similar way this building is done that work is been equally balanced in for 1 to 7 days. In the 1 to 7 days we have only work for the crane only for the 6 days. So on the 6th day we do this on the first floor slab screed, and then finally the roof elements on the 7th day. So to achieve to do the erection on the next day, we should have we should use the admixtures in the screed so that we get the early strength. Yes, sir. Sorry, you're saying something.
Yeah, earlier you said that there was some cantilever canopy of 4 meter by 10 meter size.
Yes, sir, that is there.
So what type of special precaution you have taken in erection of that canopy? Because 4 meter by 10 meter is quite a big cantilever to be handled in precast. So what special care you have taken in that case?
So we have kept this temporary scaffolding in place before we do the erection of it. And once the one more major thing is while doing the scaffolding, we have to make sure that the ground is leveled and compacted properly. What happens is with the naked scaffolding, it will be standing properly. The moment you load it on it, then maybe any of the support is may goes down. So I preferably, if there is a chance of any PCC or something, better we do that first, and then you do the scaffolding on top of it. You erect this kind of challenging elements. So once this is done, then immediately it is having a inverted beam model which is connected to the wall panels. So we again the reinforcement works and has to be done. We should have a timelines whenever we are touching this kind of typical like critical elements. We should see that okay, once today is erected and tomorrow or day of maximum by tomorrow evening, that it should be concreted. Then only the load transfer will be started happening to the walls. Otherwise, the entire load will be on the scaffolding, and somebody find some rain comes or something happens, then the element goes down.
So basically, we need to ensure that there should not be any settlement of the formwork that we are temporary propping that we are doing for this cantilever type of precast elements. That is what
Exactly,
you want to say, right?
Okay. Exactly, sir.
Okay, fine. So I think we'll move on to Mr. Amit Bade about his point of view on the planning of these erection sequence, how he is tackling these type of things in his organization.
Yeah, do you see my screen now?
Yes, yes, but we cannot see you. Yes, now you are visible. Correct.
So yeah, I think planning wise, like I said, I would like to again and again stress devil is in the detail. Precast concreting, that way, if you see, it's much less forgiving compared to your cast in place concrete. There, even if you couple of things are missed out, it's easy to adjust at site. It is easy to manipulate on the go. Here, half of your structure is already ready in the factory and ready to go. Moment you start realizing problems, when the elements start coming on the site, you have issues. So everything lies in planning, right? You need that extra care, extra attention, extra understanding of the system. What I'm showing on the screen is actually our now live project, right? In here, each element by element is sequenced. The site team has the freedom. We have 3-4 different options. They will go through it. We'll brainstorm. Even on the go, sometimes we will change the sequence, saying, okay, this is not working the way we had thought. You probably would be expecting or plan for 15 problems, and you will get 19 problems at the site. That's usual. Whatever you plan on paper may not exactly work also. But the key thing is to have it planned, so 90-95% of your troubles are avoided. You only have to deal about 5% of the troubles. So here, like again, instead of floor by floor, we are looking element by element. Each element has its own identity. Each element is numbered on the drawing. Unlike cast in place drawings, you will see a great range of detailed drawings in your GA drawings, which what we call that to be used at site, and of course the production drawings. But today's focus is on the GA drawing or the erection drawing. So each element will be numbered, and the team or the tower in charge knows exactly what sequence he wants to go. Right. Once you start looking at this element by element sequence, you are going to see a lot of times saying, if I put element A before element C, it doesn't work. He cannot erect the element C later. So that has to be looked at in detail by the design itself. A lot of times we will change the design philosophy itself just to make it work, that the sequence works on site. Now, once you figure out this sequence, remember, things are going parallelly. I'm not erecting only one tower, I'm erecting 10 towers on the go at any given time. At our site now, this project, we're having 10, the factory is supplying to 10 towers. So factories, even if it's planned just in time, factory needs to have even more detailed planning, what to send at site and at what time. So now the details on the screen, you're not going to be able to read it in full, and that's how I want it to be. But if you start looking at it in little zoomed up way, each element, each truck is planned saying what time it could leave, how much time it will take to load, when it to be dispatched, what is the travel time. Our factories are usually nearby. We set up the factory for the project itself. But all that calculation, thinking when this truck will go to site, when it will unload, whether it will erect or keep it at site, how much time it will take to come back. This entire now thing, 5 years ago, we did not even look at it because our elements were still smaller. We are doing 40,000 elements, 50,000. The projects now that we are taking up, like I said, a lakh of element or 3 lakh elements. Every day we are looking at erecting 150 to 200 elements. So you need to have that kind of planning. It could be customized to your needs. For a villa, it would be a different planning. For a large project with 10 towers going, it would be a different planning. But somebody has to give that attention to that planning. It may not again work exactly the way you plan. It never does. That's fine. I think like somebody had said that no war has been won without a plan, and no war has been won with the plan. So it goes hand in hand, right? On the go, you have to change things, but that planning you have to do, make sure that the team understands, right? Because now if you are saying one factory is supplying to 10 towers and those 10 towers have their own in charges, if that in charge has a goal of just finishing his tower, this whole program is going to collapse, because then it all depends which truck he takes it, which elements he takes it, how much time he spends on erecting or storing the element. But if those 5 tower in charges are working together with the factory, making sure that the goal is not his own tower or her own tower, but the goal is to erect your number of floors that you're targeting per month. And if that hand-in-hand planning is in place, even if 70% of that is achieved, you are going to hit your goal. So that's my take on the overall plan. Thanks.
Okay, thank you. Now I think we should start talking about the logistic part a bit in detail, like how do you do your facility management? Like how do you plan the logistic part of it, construction? Means how do you sequence these elements? Do you use any softwares, any BIM softwares to plan your elements? Mr.
Your
Amit?
question is again, yeah,
Yes,
continuing.
yes.
All right. Yeah.
Yeah.
So there is no escape to getting into digital when it comes to handling a lack of element. For the same example, let's say I'm doing. So you can't escape that. Earlier projects we have done traditional planning where you're using Excel spreadsheets, you're tracking it daily, and that doesn't help. One of the biggest thing is because the Excel kind of lags, right? Somebody is putting the data, let's say yesterday's work, whatever 20 elements you erected yesterday, somebody is going to probably get that information next day morning, then they will put it in the Excel, it will be circulated. By the time you flag the issue, it's 2 days gone, right? Or if somebody at the senior management level, if he wants to or she wants to review it, another day is gone. So digital, in our mind, there is no escape to digital when it comes to precast. Now in our, I think L&T, fortunately, I think the management had this digital vision since 2016-17 timeframe, and there has been lot of impetus has been given on adopting digital in construction. Every facet of construction you are seeing digital, including our workman training to actual site monitoring. Everything is in the go. Actually, lot of things are already been converted to digital options. So of course precast is also not behind. So I'm just going to show you a couple of slides where we are using precast in the digital space.
So are you also using RFID tags for tagging your elements, or you are printing those element numbers on those every element?
Yeah, RFID we were exploring. You guys see my screen now, right?
Yes, yes, I can see that.
1 second, actually not one. Yeah, you see my screen?
Yes.
All right. So yeah, I think RFID we have been exploring, but that is kind of a Mercedes of digital when it comes to construction. If you want to pay that kind of premium, yeah, that would work well. Probably not needed, where at least our internal scale is based on, because we are not shipping the elements long range. Factory is also close by. But we adopted that QR code system, which works the same way, but much more economical compared to your RFID space. But so if you look at this screen now, the whole heart of that project is going to be your BIM model. Of course, BIM is now gaining momentum, so you're seeing that benefit already. Within L&T also now we are mandatorily using BIM for all projects going forward. We have gone through last 3-4 years of that journey where that steep learning curve is done. We are somewhere at the peak. This project also, Provident, that I showed earlier, that was done in conventional 2D drafting. This project we have done entirely in the BIM model. So that BIM model is your heart of the entire planning. Everything kind of revolves around that. There are Revit option, Tekla option, different options are there. A lot of people are now getting into for the precast system as well. But now to link that to your BU, to your client, to your design department, to the factory, to the site, and to your overall planning. We have an in-house app that kind of we have developed on our own. We have a digital team inside that kind of supports it. Very fascinating stuff. I don't understand half of it, how they build it, how they overnight bring this magical apps in action. But that is helping a lot. That app is now kind of, we have rolled into version 2. We are going through that phase where the teams are gearing up and starting to use that app. But once I use that, the entire element, again, that element by element, right? That's where that app you cannot escape. Digital you cannot escape. Entire thing is done. Production drawings are directly generated from that BIM model, including the reinforcement. So no matter what, how complicated my element is, earlier jobs we used to actually draft this in AutoCAD and then do the reinforcement detailing. Now this is all modeled, and maybe about 5 to 10% of extra work for detailing, finishing, you get the 2D drawing. And once that is done, this is our app where we are tracking that each element throughout each stage. So even for my quality control, even for my record keeping, not just planning, that entire element is tracked through his life cycle history, like when it was cast, when the bed started, when it was demolded, what strength it had when it was demolded, where it was sitting in the yard, where it is being shipped. That entire, this is the live real-time snapshot what we are looking at. What I was telling that Excel, it takes 2-3 days. Here, that the moment the element is erected, it gets updated on the portal. So even if you log in at 9 p.m., you are going to see this real-time snapshot saying how many are supposed to cast, how many are already done, how many are on transit, how many are actually erected. And this is updated real-time. This is the strength of the digital what we are all trying to capture, and that improve that productivity. Right now, that's erection. I get the same snapshot for the projects also. These are all my 10 towers going on, and each tower status, planned versus actual. You can get to track it and do it. So that we are also evolving, learning. I think we probably have not seen many companies do that. We are probably on the forefront of getting this digital into precast system, but we are at a good place where we are really looking forward to that real-time tracking, the digital twin model concept what we are bringing up now, that this whole real-time update will actually go into the BIM also. And next step is that 4D whatever, the same model updates, then that same model is used to the client billing also. So what we were doing this billing also manually, that automatic billing, automatic, how much quantity of work is done, what is the cubic meter of the concrete, everything is being pulled up directly from that BIM model through the app. Through we have another billing app. So there is a entire system of digital that we're planning to build around the precast technology.
Okay, great. Yeah, good to see that you're using the technology to its fullest extent, automating the construction processes. Now, I think I'll ask Mr. Rambabu about, even though we are doing all these things, there are going to be some sort of troubleshooting at the time of erection. So what is your experience in troubleshooting type of thing? Like what type of experiences you come across, and what type of troubleshooting methods you have developed to counter those type of unexpected situations at site? So can you throw some light on that, Rambabu?
Yes, sir, sure. Actually, for the successful journey of precast, the erection is the final and the keys milestone, I feel. So people actually, they doesn't normally the scenario is like that. They doesn't care in the production, they doesn't care in the design stage and in the logistics stage, and finally it comes and boils down on the erection. So the thing is, we should control everything in the each and every respective stages. So let me show my screen. I have prepared some small PPT on it.
Okay.
So only the way is quality control checks to be in place at each and every stage. Like in the production, we should not end up only before casting only we should do and then come out of it. I'm not getting permission to share my screen.
Bhumika, can you allow Mr. Rambabu to share his screen?
Yes, sir.
Yeah, now we can see your screen.
You can see my screen now.
Yes.
So as I told you, we have three, we need to control the element quality at the 3 stages before it reaches to the site. So first is at the design stage, and second one is at the production stage, and third one is at the logistic stage, at the logistic plan. So in the design stage, actually what happens, sometimes some sort of revisions happens by the architecture or MEP, and that won't be put into the shop drawings. So finally what happens is when it comes and get erected the site, and then the MEP consultants and the architect get surprised that, oh, my things are not get being went to the ground. So that is the critical area. What I feel that, okay, is there any revisions happens from any side, either from the structural side, that element has to be revised and it has to reach to the shop floor at the earliest before it get cast. Once it is casted also, then we have to issue the drawing stating that, okay, rectification, for the rectification, instead of for issue of production, you can issue for the rectification, so that whatever the things to be happen, it happens at the production at the factory level and it reaches to the site in a desired way. When it then it goes to the production, even though we have a shop drawings, proper shop drawings, and the layouts is in place, sometimes what happens is the production checks lapses. Like I personally feel that the production should happen in 3 stages. One is before placing once the mold is fabricated, either with the magnets or whatever it may be, magnets or the nut and bolt systems, or other stuff. Before placing the reinforcement cage, we should be in a position to check the dimensions of the panels and properly, and then also see that is there any coming on the mold face, any cutouts are there, all those things to be taken care in the production. Then the second stage, second check before pouring the concrete. Once the reinforcement is caged, all the MVP connections are in place, then again we need to check it. So this is the critical check which hampers the erection a lot, like the double two position and the starter bar locations and the loop boxes location. Is there any some boxes extra reinforcement will be given for the moment connection? Those things should be in place properly. And then the third check in the production is once the casting is done and the molding is done, before it dispatches to the site, we should have a system in place that, okay, that is called post pour. Then there I prefer to use some kind of paint mask, like green is for the allowed, and the red is for the orange is for the rectification, and the red is for the rejection. So is there anything is there, if they found anything before getting dispatched, then it should be kept aside and then do the repairing and send it back to the site. So the site should accept the elements which are having the green mark. And then when it comes to the logistic system, that in our India we have a system called we have a maximum loading of 26 to 30 tons. So we should not overload the elements in the hurry of saving money. So what happens is it will why, because it is not a smooth road. We will having a lot of speed breakers and turnings and all the stuff. So what happens is the element gets break, and then no one recognizes until it reaches the site. So that the packing, and then if you are stocking a hollow core slabs basically, then from the end by the L7 we should keep the supports, and then we should keep one above other. So that whenever the moment during the moment the load transfers properly to the ground, instead of, if all the supports not in one line, then there is a chance of breakage of slab or wall. So then the major challenge that is on the micro level. That is on the macro level. Coming to the micro level, what happens is in the erection. So these are the major areas, the 5 areas where we need to focus basically. The double tube locations and the post to be done properly, and then whatever the casted slab, the screed slabs to be in the proper level, and the starter bars should be in vertical in position. Of course, it is in position, but it has to be 90 degrees. Otherwise, while placing the elements, it may go, it won't be fit within 15 to 20 minutes. What is our desired thing? And third thing, the final thing is the element thickness. So if the element thickness is not in proper, what happens is in the alignment, we will not be getting the room dimensions properly. So these are the 5 areas where we need to keep on focus. So as I told you, if we do all this excess much before it reaches to the site, we will not be facing any issue at the site. In case by any chance if we miss, then there are some minor rectification process in place which can be done. Like first is like double tube widening can be done with by using the drill bits, and then hammering of the starter bars up to a small extent. It's not like 100 mm, 200 mm, maybe up to 10-20 mm we should be able to do. What happens is everybody is like, okay, double tube 9 mm, then you hammer the rod. We should not do that. Why? Because if you look at this structurally, the load transfer happens vertically, top to the bottom.
Yeah, normally
So,
we structural engineers fear about hammering of the dowel rods.
yes,
So
yes.
that should be done at the least possible times. Yeah, sure.
Yes.
Yeah, you can.
And then when it comes to the slab levels, what happens is if slab is normally the screed slab won't be up to a 0 mm tolerance. So what happens is there will be some 5 to 10 mm that can be adjusted with the help of sim pads what we have. As I told you, we will be in the precast as a standard, we will be maintaining the 20 mm gap. So if it can be of 15 mm or it can be about 25 mm, that doesn't make that doesn't matter a lot. But only the thing is the top level should be the wall, the top of the wall should be in the plane so that it takes the slab in a proper condition. Otherwise, again, we'll be ending up chipping either the slab or the top of the wall panel. So in some cases, some mistakes may happen by the structural engineer, some production, something may go wrong. In that case, what we need to do is we can with the after taking the approval from the structural engineer, we can fix the double bars by using the chemicals. I prefer that Hilti RE500 so far proven. Of course, the other products also there. But according to the double position, we need to chemical anchor the starter bar. And then there are some surprises we get that okay, some panels completely casted mirrorly. What happens is in the production, sometimes for the ease of production they mirror it instead of mold face, they mirror it, and then they forget to mention on the element that it has been mirrored. So in that case, what happens is in the lower level, if the element gets erected wrongly, then the starter bus location in the upper floor get differ. So in that case, since we will be having a typical floors like this, so here the maximum elements will be symmetrical. If you take any apartment, that can be symmetrical. So whatever the element came, that can be used in the other flat, and then for this particular flat where went wrong, we can produce a separate element by using the starter parts locations available at the site. So this saves a lot of time and also reduces and also it will not spoil the building strength. And then this is some small example of the double tube widening. So as I told you, only the thing is we should do the checkings at the these 3 stages properly. And also at the site, it should have a proper numbering is in place. Normally what happens is the site, people they write with some temporary markers and number gets erases. And then there will be a lot of chances like even though as I told you in the typical floors, the dimensions are the same, but the MEP inches are not same. There are possibility of the erectors picking the wrong element and then erecting it, and then the MEP goes wrong. So that the numbering, the identification of the element should be written in the multiple directions, not only in one place. Of course, if you have a barcode system, that is also more better. In the Shobha, we have used the barcode system, where we used to we used to attach it during the production, that barcode, and then once it is produced, then we scan it, and once it dispatched, one more scan, and once it reached the site, and that is the last but one scan, and once it is erected, the final scan. So this way you can scan it with this barcode system.
Does this barcode help us in locating the element on site? Because sometimes it happens that the element is lost on the site and then people scramble to
exact
locate the
location. We can feed it, sir. Actually, while doing this scan, we can see that in the stockyard, if once it is received at the stockyard, we have a in the Shobha we are using the A-frames. There we were using close to 80 A-frames we are using. So the element went to the 60th number of box frame. So then we used to enter that okay, this scan it, and then we are showing that, okay, it is in the 60th frame. So while it is going to the site, no need to do the scan for the complete 5 or 6 elements which is sitting on the box frame. We can scan one element so that it shows that it is in dispatch. Once it reaches the site, then if you do the barcode, then it says that okay, 60th rack is there. Once it is unloaded, then the data in that 60th box frame get erases. Of course, then we can go to the back data and then see that okay, on particular date, what was used for the in which box frame this element was transported. So that tracking can be done with the help of barcode.
Okay, fine. Yeah.
Yeah. I'm not showing
Okay.
much rectification picture so that the people get scared.
Yeah.
Only my request is only please take care during the production as well as in the logistic plan so that we will have a beautiful time at the erection.
Yes, sure.
Over to you, sir.
Okay, so yeah, so we are running short on time, but we'll quickly try to see Mr. Syed, what is your experience on these erection tolerances, how they are communicated with the site and how they are observed and how they are maintained on site? Mr. Syed, can you throw some light on that?
No, it was just got disconnected. Can you just repeat?
Can you just throw some light on like the erection tolerances, how they are communicated to the site team and how they are tracked, whether the element erected are within the erection tolerances, and what is your experience on that front? Do you face any challenges in achieving those erection tolerances, or you feel those need to be a bit liberal or a bit tighter?
No. The tolerances for erection and production both are elaborately given in the PCI tolerances. So
Yeah,
always this selected.
we are not able to see you actually. You need to turn on your.
The erection tolerances and production tolerances elaborately given in the PCI manual. So always these tolerances goes along with the method statement. Always, whenever we are giving the method statement, we always attach one copy of the tolerances for each kind of element, what tolerances allowable as per PCA, and same thing has been communicated to the the erection team also. Always one toolbox talk as well as method statement briefing talk before starting the activity, any new activity. So it will give to the even the erectors also, not only supervisors, engineers. It will give clarity on what tolerances is allowable as per the PCA. So that's how we have to. We always minimize the tolerances, the challenges on the tolerances.
Okay. Mr. Amit, what is your take on this erection tolerances? How do you communicate those to your site team and how they ensure that they work within those tolerances?
Yeah, I think I can talk all day long about these tolerances and over erection items at site. But if you are seeing my screen now, I think I'll just quickly, I know we are running behind already, but we have, I think, one overall erection in charge at site, and every time we start the discussion, his famous quote always is, "वो ऐसा 0-0 में मिली में नहीं होता है precast," right? And that is correct, right? We are, I think, on we have now tolerances in IS code also. 15916 is there. We have incorporated, and those are actually somewhat liberal tolerances also. But even with that, if you're handling an 8-ton element and you expect the site to erect it at 2 millimeter tolerances, that's not going to happen. That understanding has to come from the designer. That understanding has to come from end user, client, everywhere. Having said that, we don't want to give the license to do anything and everything to site as well, right? So we have to have somewhere that balance in between. And we actually went through this challenge a lot over last 6-7 years, where when we did our first job, all connections were using these dowel tubes, right? And everything revolves around the connection, whatever, whether structurally one, that is my main interest, but at site also, the way you detail, the way you design your connection, if it's workable at site, if your site accepts it, then only you're going to see that productivity. So we used to have this dowel tube connection everywhere. which honestly, before I came back to India, I had not seen these dowel tube connections the way we are using for lapping the bars and all. I have always seen when I started outside using this grouted coupler connections. So that dowel tube, when we went through it, for a lack of better word, it almost came to it saying that tolerances were being abused. Right? We have a 20 millimeter bar, and you are giving a 50 millimeter dowel tube. That means you are giving 30 millimeter leeway to site to do or use it whether for good or bad, and then your alignments are going to be off, right? So we saw that in the first project, no matter how much care you took, because your erection in charge will understand that, but our sites are working 24 hours, right? We work in 2 shifts. Night time, even if we have an in charge at site, he's not going to be able to be at every element erection. We are erecting 25 elements per shift, let's say. So somewhere it's going to get abused. By the time you see it next day, that alignment is gone, the offset is there, the grouting is done, and now you have to deal with that offset. So we took this conscious call for this next projects where we are using these grouted couplers. Now these grouted couplers, everybody is aware structurally, actually they perform much better, where I'm not actually using the better performance towards design yet. But more than the structural performance, we like this for this erection tolerances, because these couplers have low tolerances. If you want to see, look at the picture. I'll come back to these slides, but these are these couplers what we are talking about. And for a 20 millimeter bar, you are going to get a 40 millimeter inside, approximately. Exact numbers would be different, but that tolerances are less. But those tolerances actually are matching with the intended tolerance of the code, where the code is saying that your 2 panels cannot go off more than 3 millimeter, or your panel length cannot be off more than 5 millimeter. These are based on that, and it's widely accepted in outside industry. Like I said, last 30 years outside precast industry, both European and American have been using these grouted couplers, and they actually give you that limit, right, where it comes to a stage where if it's not fitting, it's not going to fit, no matter how much you hammer your dowel. Like we were discussing about hammering slightly, joggling and all. We give instructions that zero joggling, I am not going to permit any joggling, but some happens. Now with this coupler system, if it's beyond your limit, no matter what you do, your panel is not going to fit, where the site will not have a choice but to send it back or raise it to some design issue saying what we need to do. It's not easy to manage or manipulate that element at site during your construction. That was the goal, and that's what we found out, that the benefits of these couplers are more in terms of your managing tolerances, managing alignment at site, and overall quality control than the structural performance. Talking about structural performance, though, there was a lot of reservations earlier also saying my lap is always, we are used to seeing this 50 bar diameter lap, and now suddenly you are saying that only 200 millimeter projection is enough to develop the bar and all. So we went through that phase. So we had actually our own in-house program. What you see on the screen, we actually did a full-scale testing where we built this 3-meter tall shear walls, what you see on the screen. Yeah, so these are like 2 shear walls, cast in place and precast. So we just wanted to verify the behavior, how they mimic, whether they give equivalent performance or not. And this program was done in line with IIT Madras and SCRC Chennai, where this full height 3-meter walls with the slab, with the dead load of about 10 to 15 stories on top of it. And using this reverse cyclic actuator, they were actually kind of pushed pull to get your load versus deflection. So we wanted to just monitor whether the cast in place and this coupler or precast joints. It was not done just for the coupler. We had other precast joints also, this conventional dowel tubes. Now, if you see this curve, usually the first tendency to see, oh, this is your cast in place and this is your precast. But if you look at that, this is actually my cast in place wall reaction, your load versus displacement. For the structural engineers here, the area under the curve is what your ductility is, or your R value is. And if you see this SW2 and SW3, which are my conventional precast connections using the dowel tube and all, they are also giving me the same performance what a conventional wall give. The coupler one, which is SW4, however, gave me better performance. because it is giving me better performance compared to conventional lab because of that extra confinement that the metal tube is giving around it. That's how you get the performance. That's how even the 200 millimeter embedment into that coupler is giving me satisfactory performance, is that confinement, right? That's how
what type of grouts were used in these couplers? Were they 60 MPa strength, 80 MPa, or 100 MPa?
No, so yeah, so for that embedment and all, you need M100 grout, at least M95 plus, to get your ductility. So if you use the M60, this is one thing actually a misconception in the industry, which now that you gladly pointed out. If you use M60 grout and if you do a standard pull-out test on these couplers, it is going to pass. It will hold, it will break the bar. What the code is expecting is reverse cyclic behavior under seismic performance, where this type 2 test now, there are modifications where currently we have only this American codes, which our current IS code also has brought up the fatigue test and all, but they are somewhat different. But the idea is to undergo or evaluate the performance under the reverse cyclic load. So if you see this test, this was done in 2016, at that time in India we did not have any lab which can do the test, so we went to Hong Kong and got these couplers tested. But on this curve, if you see, this couplers bar has been pulled and then pushed back. It is your 95% to 50% compression to mimic that reverse cyclic load under seismic situations, push and pull load. Once that is done, then it is
This was done for 10,000 cycles, or how?
No, this is not the fatigue. So this is your ACI type 2 test. So what they do is for 20 cycles, this is what the code is required. This is for structural load. The 10,000 cycle is where you get the bridges and all, where you actually see the fatigue. In buildings, you don't see the fatigues, you see the seismic behavior. So this is done for 20 cycles, but then it's pulled to twice the yield, another 4 cycles. Then it's pulled to 5 times the yield, another 4 cycles, and then it's pulled to failure. And the requirement is the bar has to break, not the coupler. Now, if you do M60 strength, this will never pass. That's why we need the M100 grout, high strength, very high strength grouts, to get through this reverse cyclic load. If you're using these couplers for your standard gravity connections, where no lateral loads are present, no seismic, then M60 grout is fine. If you're using this connection for your structural tall building design, where you are expected to see lateral loads, then you need that M100 grout. M95 plus is what we are looking at, our own test, because we had our own in-house grouts also tested, which did not do well. So we bypassed it. We are using only this M95 plus grouts. But with this, actually structural one, but like I said, today's team is more erection challenges and all, and we are seeing much better performance in terms of overall maintaining the alignments and overall differences between the elements.
Okay. Okay, so I think we have covered most of the topics, and we have many questions from audience side. So I think we will start taking some of the questions. Some of the questions are like, there are some red flag questions which are more like, there is a question about how safe these precast buildings with respect to failure from connection during earthquakes. This is a sort of very basic question, so I thought I will take it. Mr. Amit, what is your take on this?
Yeah, I think this we have gone through several rounds now. Buildings are, I think if I have to cut it short, these buildings are absolutely safe. There is no issue, no doubt in our mind. If we had, then we would not have gone and built these buildings. We have done enough experimental verification, also validation. The test that I showed you now, the entire test program is done within L&T, just because we wanted to be sure whatever details we are using, are they giving the satisfactory performance or not, even if those were used outside for several years. What we are using now currently is the emulative detailing option. Whenever these usual concerns about the structural or seismic performance and all comes, or failure of connection comes, is for welded and bolted type connections. That's what the outside industry is using. Nobody in outside using the connections that we are using, the stitch connection, wet concreting. Everybody is moved to dry connections because they are much faster to build. But those concerns are there, where of course they have enough research for those also, but they need extra attention. The detailing that we are using, where we use cast in place stitching, we get that emulative behavior. Your buildings are going to perform exactly similar to what a conventional construction building will perform, and we have done that enough validation, enough peer reviews using all leading institutes including the IITs, and we are very comfortable with that.
Mhm. Okay, so there is another question about applicable codes and joinery or cementitious grouts and test for checking of the joinery. There are different codes available. I think in India also we have a precast code IS 15916, and plus for grouts I am not sure which codes are there. Are you aware of any code for cementitious grouts? I think these are engineered and tested products, so probably cannot be covered in any code. But Mr. Amit, do you have any knowledge about any codes related to grouts?
Yeah, I think there's ASTM codes are available, which has been used even in India. I think we have IS codes. The name is not coming up the top of my head, but the codes are there where you can test the grouts.
Okay.
So the standard concrete cube testing requirements should not be adopted for the grout testing. That is one thing I would like to stress here is your conventional concrete cube test, your grout will not behave the same way your concrete does. So please make it a point that do not test your grouts using a standard concrete cube test.
Okay. Then there is another question related to are there any standard panels readily available, or those or they are on demand customized? I think standard panels I don't think anybody is making, probably maybe for some non-structural elements. Rambabu, do you want to say anything on this? Are you making any standard panels in your factory?
No, sir. The standard panels
Maybe for
won't work
compound
out for
wall
everywhere. Yeah, for the compound wall, it happens. We can use
but
it.
not for
Normally, we
building.
do a compound wall stretch of 2 kilometers or 3 kilometers. For the buildings, it doesn't work out.
Yeah,
There will be having a MEP has to be in place.
Okay. And plus, there is another question about there are so many questions. I'm just trying to see the red flag questions, which seems to be important to the screening committee. Then, what reinforcement percentage is normally used as per client or for consultant drawings? Normally, there is no standard as such for deciding reinforcement percentage. It depends on the load on the structure and the structural configuration. So there is no definite answer to this, that any particular reinforcement percentage is there for any type of building. It depends on the span and loading of that building. And there is another question, that is precast done for foundations also?
Yes.
Yeah. Can you share some light on this? Have you done anything on this foundations? Mr. Syed?
It's very much possible. That depends on the design. For villas and all, we are doing precast foundations. For multi-story buildings, it's very difficult because the handling is the challenge. For raft, no way. For isolated footings, yes. It completely depends on the size of the element, foundation sizes and all. For villas, yes, definitely we are doing precast foundations.
Mhm. Okay.
G+2, G+3, we are going at precast foundations only.
Okay. Then there is question that can Government of India through relevant agency oblique agencies play significant role in popularizing precast construction in this India? If yes, how? Mr. Syed, do you have any information on this?
Already SR rates are there in CPWD. Already Government of India is already captured the rates. Yes, now government also that floating the tenders on precast only. There is no special board or special entity to promote precast. There is no such kind of entity in India.
Mhm.
Even in the Indian Railways, now they have started doing a compound wall in the precast technology. In the UP, it has been already started by using the hollow core slabs and the columns, foundation, everything to be in precast.
Mhm.
CPWD,
Yeah,
PWD.
here, yeah, I think I'm sorry, but just to
Yeah.
interject here, I think BIS actually last few years they have been extremely helpful. I think Mr. Pant, there are many things are in motion now to get the codes updated. If you see even the 15916, we have the latest now 2020 version where many items or whatever challenges faced by the industry are included in terms of test criteria, and that's a very good reference. We have an old code IS 11447 also, which is will be updated now shortly too. So actually BIS has been putting a lot of efforts to get the framework ready where precast system would be accepted, where that usual question of saying, oh, IS 456 does not have information about precast, so what do we do now? So with these updates, where it will come to is, of course, like I said, we are using emulative detailing. So with the detailing, we pretty much follow that IS 456 details for the as far as the structural design is concerned. But with these updated codes, we will have that backup where that link would be there, where you can push it saying already IS code has the relevant information in built. Where so far we have been always going back to PCI handbook or Eurocode for precast construction.
Okay. So I think there was one more question about SIDCO related thing. Like, sir, in SIDCO package, 4 columns will be in casting situ or precast. Okay, so that is specific to your project question. That whether there will be some CIP columns or precast columns, something like that.
Okay, I don't see the question, but what we are doing on the precast scope is everything superstructure is total precast. For the stilt level, we have cast in place construction. We don't have very many columns overall in the building itself. It's a load bearing shear wall system on the project.
Mm-hmm. One question is repeatedly asked by 2-3 participants about how safe is precast construction from normal construction with respect to earthquake. Basically, here I would like to tell that even in most seismic areas of world, like San Francisco, the west coast of US, there is the precast building which is around 39-40 storied, which is completely in precast and satisfying all the seismic requirements. So, and that building is standing there since last more than 15-20 years. So that thing is nowadays proven that the connections can be designed to withstand the heaviest earthquake load, so and provide the necessary ductility criteria. So since I saw that question 2-3 times, I just thought I would answer that. And there is one more question about how about the heat radiation in precast panels when compared to conventional brick masonry. Rambabu, would you like to take this on?
Yes, sir. Normally people think that, okay, precast building gives gives a lot of heat to the, you want to say the heat into the building, you want to say?
Yes, basically the question is that whether the precast panels will radiate more heat as compared to the brick masonry walls.
Absolutely,
And
I
if
can.
so,
We can't say that, okay, at the higher temperature areas, there we can go for the sandwich panels. That is a normal case. But in comparison with the brick masonry, I don't agree that it will give more heat radiation comparative to the brick masonry. Still, it will be having much fire resistance and a lot of other things also is in place.
Mr. Amit, your take on this about the heat radiation of precast panels as compared to brick masonry, because this is also a generally asked question.
Right. Yeah. See, as a material, your concrete is not going to match the thermal performance of brick masonry. That there is no doubt about it. If you are looking comparing about a 200 thick block masonry, you will need a 500 thick concrete wall or more to get the same performance. Right. That is the material. Same steel will behave differently. So yeah, we all understand that brick thermal performance cannot come. Having said that, we are now switched over where we are using RC building. Forget precast, now concrete buildings where we are using this aluminum formwork system and all. So that question came all the time, saying what happens to my end user. So what we did about 4 years ago in partnership with IISc Bangalore, we did a one entire year-long project where all these block masonry building and our RC building in 4 different regions of India, including Chennai, including Mumbai, Ahmedabad, different regions we wanted to monitor. And then the inside temperature was monitored throughout the year compared to the outside temperature and see what the difference is. And the conclusion of the exercise was, if you have a ventilated building, then the difference between these inside temperature was hardly about a degree and a half between these 2 different systems, provided you have a ventilated building. If you say a concrete box versus a block masonry box, you are never going to get that performance. But if there is natural ventilation, which is what we are seeing in India, generally for this mass housing, there is no significant difference, is what the conclusion that report we have had. Now, having said that, we are now moving towards closed buildings, mechanically ventilated buildings. Same thing. Even that, if you have a pure RC concrete wall, you are going to spend more on AC bill compared to a block masonry wall. There is no doubt about it. But like we discussed earlier, now is insulated precast, which is what outside world is using, is thermal precast panels, which is usually not possible in conventional system. Those thermal insulated precast panels, which I have done more than 30 jobs outside where those are used as a building facade, they will perform 3 or 4 times better than your block masonry. So we are probably going to shift that. That market is coming where we have these Griha requirements or sustainability is being talked about, where we will then beat the block masonry. But purely concrete as a material, it cannot beat block walls.
Yeah, and have you any time used heat reflecting paints or something like that on the outer side?
Yeah, we have explored. Yeah, those options have been explored. They come at a cost. They work well, but then again, that overall system as a building, you can't rely on that, because heat reflecting. Your only few faces of the building will have that actual direct sunlight. Everywhere else, still is ambient temperature is there.
Yeah. Okay, so I think there are many questions, but maybe those can be forwarded to panelists after this event and can be replied, because I think we have run over the time limit. So I will hand it over to Prasad for concluding remarks on this. Prasad?
Thanks a lot. Thanks a lot, Dhananjay and all other panelists. I would have liked this to go on and on, but yes, we have got a time limit. And there are, I mean, really a lot of questions which should have been answered, but maybe we'll try to compile them and send it to panelists, and panelists I request panelists to try and answer some of those questions. This went really well. This panelist summed up the benefits of precast very well. I mean, the picture Mr. Amit Bade showed that, which was not taken on Sunday, which he specified, showed how tremendously we can increase the productivity of our construction by using precast. I think that's one of the biggest advantage, increasing productivity. And then also during the course, we learned that there has to be a lot of emphasis on details during planning. There was a talk about building the project on paper first, before going to site. So something that we all should be mindful of when we go into precast. The small details like how to manage how do you plan for eccentricity of a component which comes into the erection sequence. Then they also specified wonderfully how the inherent advantage of precast. When you are doing a precast wall panel, cast in place wall panel, it is cast vertically, and whereas in precast we are casting it horizontally, so things like groove can be very easily matched. That is something which was really good. It was nice to know about L&T doing such wonderful testing for full scale dynamic load test and cyclist test. It gives you assurance that we are building safe, and quality of our testing is also nice. It was also nice to know that we are also looking at insulated panels and digital drive into it. I think our SEMCON would be a really interesting thing, because there we are going to discuss all these things, in a more detailed way. And I really appeal that everybody who's listening this should make a point to attend SEMCON, where we have got entire 2 days to deliberate on this, and there will be also a chance to meet all the fellow professionals, which perhaps we are getting after 2 years, meeting them personally. So all are welcome to the SEMCON this year at College of Engineering, Pune, which is a very old, renowned institute, established in 1800. So that's something where we are all looking forward to. Thank you. Over to the vote of thanks by Ultratech.
Thank you so much, sir. I would like to thank all our panel members for such an elaborated and interactive session. Also, thank you so much, Dhananjay sir, for moderating the event. Now, a quick update on our next webinar session, which is on November 13th, 2021. The webinar is on very captivating topic, that is durability design of concrete structure, present provisions and future changes in IS 456, why and how, by our very eminent speaker, Engineer P.N. Ojha, who is Joint Director and Head of Center, Construction Development and Research, NCCBM, Vallabhgarh. Link to register will be provided on your registered email ID along with participation certificate for today's session. Now, I would request Engineer Vipin Chaudhary sir to please do the vote of thanks.
Thank you, Bhumika. First of all, let me thank all the panelists, Mr. Amit Bardaji, Mr. Yogesh Kajlaji, Mr. Rambabu, and Mr. Sayed Bhashaji. Mr. Kajla is not able to join, but and I really thanks Dhananjay ji for doing as a moderator, and I really appreciate that ISA Pune Center has in joint association we have conducted this session, and definitely, sir, we will do more such session in the future also, because we have a one joint purpose, that is the knowledge dissemination. And today we have done the panel discuss the various challenges and the aspects about the precast execution challenges, and the case studies which are shared by Mr. Rambabu and Mr. Amit, definitely they are covered all the aspects of troubleshooting also, and I really appreciate, and definitely precast technology will be the future for the new rise India. And I really thanks all the participants and all the executive member of ISA Pune member for this session. Thank you.
Thank you so much, sir. So I once again would like to thank all our participants for sparing your few hours of your valuable time. Special thanks to all our panel members for such an informative and detailed presentation. We hope you find all this content valuable. Thank you for your participation. Stay tuned.
Thank you.
Thank you. Thank you, everyone.
Thanks, everybody.
All right. Thank you, everyone. It was a pleasure to be here. Thank you.
अभी तो बजट टाइट है दुबे जी, मैं कोई दूसरा सीमेंट आपको सोचकर बताता हूँ।
पापा गड़बड़ हो गई।
डोंट वरी बेटा, हम फिर से बना लेंगे।
राजीव, कोई दूसरा सीमेंट आगे चलकर कोई गड़बड़ हो गई तो?
डोंट वरी मम्मा, हम फिर से बना लेंगे, है ना पापा?
अरे ऐसे नहीं होता बेटा, घर थोड़े बार बार बनता है। हाँ दुबे जी, वो सीमेंट सिर्फ अल्ट्राटेक ही लगेगा। हाँ बिल्कुल पक्का।
घर बनता है जिंदगी में सिर्फ एक बार, बनाइए इसे देश के नंबर 1 सीमेंट से।